Suppose that we have two resistors connected in parallel with resistance R sub 1 and R sub 2 measured in ohms. The total resistance R is given by. First, we need to write the formula, which is 1 over R equals 1 over R sub 1 plus 1 over R sub 2. Suppose that R sub 1 is increasing at a rate of 0.4 ohms per minute and R sub 2 is decreasing at a rate of 0.7 ohms per minute. At what rate is R changing when the given is R sub 1 is equals to 80 ohms and R sub 2 is equal to 105 ohms? Unlike the previous problems, there really isn't a whole lot to do here. First, let's note that we're looking for R prime and that we know R prime 1 is equal to 0.4 and R prime 2 is equals to negative 0.7. Let's be careful with the signs here. Let's proceed to solution. First, we need to substitute the given R to our formula, and that is become 1 over R equals 1 over 80 plus 1 over 105. So if we calculate it in scientific calculator, the answer is 37 over 1680. To get the 45.4054, we have to reverse the 37 over 1680. Next, we need to differentiate the equation given in the problem statement. So I move the R squared here to get the final formula that I will use. So it becomes R prime equal R squared, open parenthesis, 1 over R sub 1 squared R prime 1 plus 1 over R sub 2 squared R prime 2, close parenthesis. We need to substitute the given R to formula, and to simplify, I use the calculator to get the final answer to this example, and that is negative 2045 ohms per minute. So it looks like R is decreasing at a rate of this. Two cars start out 500 miles apart. Car A is to the west of car B and start driving to the east. In other words, toward car B at 35 miles per hour, and at the same time car B start driving south at 50 miles per hour. After 3 hours of driving, what rate is the distance between the two cars changing? Is it increasing or decreasing? The first thing to do here is to sketch a figure showing the situation. In this figure, Y represents the distance driven by car B and X represents the distance separating car A from car B's initial position, and Z represents the distance separating the two cars after 3 hours driving time with the following values of X and Y. To get the value of X, we need to subtract the 535 times 3, which is equal to 395. And to get the value of Y, we need to multiply the 50 times 3, which is equal to 150. So what is the value of Z? To find the value of Z, I use the Pythagorean theorem, and that is Z squared equal X squared plus Y squared equals blank, and we need to get the square root of the answer. I substitute the given value to the formula, and it becomes Z squared equals 395 squared plus 150 squared equals 178,525. And to find the value of Z, I calculate the square root of 178,525, and it becomes 422.52. To answer this question, we will need to determine Z prime given that X prime is equal to negative 35 and Y prime is equal to 50. Do you agree with the signs on the two given rates? Remember that a rate is negative if the quantity is decreasing and positive if the quantity is increasing. We can again use the Pythagorean theorem here. First, write it down and remember that x, y, and z are all changing with time, and so differentiate the equation using implicit differentiation. So it becomes 2z prime equals 2xx prime plus 2yy prime. All we need to do is cancel a 2 from everything, plug in for the known quantities, and solve for z prime. So it becomes z prime 422.52 equals 395 times negative 35 plus 150 times 50 is equal to negative 6,325. After that, we need to divide the negative 6,325 and 422.52. So the final answer is negative 14.96. So after 3 hours, the distance between them is decreasing at a rate of 14.96 miles per hour.